session once the live recording is on. All right. Okay, so anyone who would like to ask questions, please go ahead. And we'll just put in the questions if we have any questions from the discussion forum into the chat box.
I see a question in the chat box. In practice, what's the length of a line for line transect and effective radius used for navigation? So the length of the line can vary. It often depends on the kind of habitat that you are surveying and sampling. So if the terrain, so pretty much here's what happens. If the terrain is very difficult, then we're using point counts more than line transects because it's difficult to establish long straight lines in, say, mountains. Um, the length of transects can vary from about 250 meters to about a kilometer. Typically, I've seen 500-meter long transects to a kilometer long transects being used to sample birds habitats. And the effective radius. So when people use what are called fixed radius point counts, where you stand at a point and then you assume that every bird within a certain radius is either visible or audible, and you will count all of those birds in that radius. Often in forests, that radius is 50 meters. So it's not, you're not actually measuring the distances of the birds from the point, but you're assuming and you're saying in the 50-meter radius, whatever I I detect with a probability of 1. There is no probability that I miss any birds. That's an assumption. The probability that I miss any birds in a 50-meter radius is 0. Now, the effective radius from actually measuring distances will differ from habitat to habitat and species to species. So, and that comes from the data, right? This is not a preset thing that the effective radius is so and so. It comes from the distribution of the sightings from your data. So, if a bird is very vocal or very, very conspicuous, you will be able to pick it up or record it even at greater distances from the point. And so for that species, the effective radius will be higher than a species that maybe is not as conspicuous or does not call as much. But for that species, the effective radius will be smaller. Effective radius can also depend on habitat. So, for example, you might be able to detect species in Jobin. Could you mute yourself, please? There's some kind of thank you. Sorry. Um, it can also depend on the habitat, the effective radius, because it might be more difficult to detect birds in more closed habitats. So the effective radius then becomes smaller than effective radius for open habitats. Capture recapture, thanks, Jobin. For n unknown, how many number of birds should be ringed to assume that the ratio m by n is equal to the ratio r by n? Um, Again, there is no one answer to this. It depends on the size of the population. The more birds you ring, the better it is. So if you have a population of 1,000 birds and you ring only 10, then obviously you're not going to be able to get back or recaptures, right? Because the next time you go and sample, there are actually 990 birds that are unringed, that are unmarked. And so you're likely to capture those unmarked birds. Right? So the more birds you ring, the better it is. So it would be, so again, there's no one answer to this, but the general rule would be ring as many individuals as possible, mark as many individuals as possible in the first go. With spot mapping, what is the methodology used to delineate the territory of a bird in the field? Uh, so with spot mapping, basically what you're doing is you are looking at something like a singing male, right? And you record the location of the singing of that male. Every time you see that male, you record the location of that male. So you put a spot on the map every time you see that. And is my voice unclear?
There's some, I mean, some sound here and there, but some clicks, something. I mean, I'm not sure what, but yeah, otherwise it's okay.
One second. Just give me a minute. Is this better?
Loud and a lot of background.
Is this better?
Yes, yes.
Okay, fine. Uh, So the spot mapping was you basically put a spot on the map every time you record a bird, and then as the spots get accumulated on the map, that then tells you what the territory of the bird is on the map. Line transits and point counts. So scientists use a combination of both line transits and point counts for getting a total estimate population of the species. Usually not. Usually you either use line transits or you use point counts based on a variety of considerations. So if the habitat is flat and it's easy to place lines, generally line transits give you much better data than point counts. So the default would be if you have the option of choosing between line transits and point counts, then go with line transits. But very often it's not possible to place line transits because the terrain is hilly and you can't place a straight line of sufficient length. In that case, point counts are used. So it's either line transits or point counts, usually not both. Um, Water bird counts. What is the methodology or strategy used when we are counting birds on water? Has to be point counts because we cannot have transects. So how do we count flocks? The birds in the water swimming around, how do we count? Especially during migration. Uh, you can actually have transits if you take a boat. People do this, take boats into the lakes and do light transits um, from boats. But usually, because the habitat is so large, if you're able to have multiple observers and you split up and divide the water body into sectors, and you have one observer counting the individuals in each sector, because the habitat is so open, usually what is done is a direct count. It's a census rather than a sampling technique. With things like flamingos and ducks and waders and so on. You've got because you can see almost every individual, so you can actually census that population. Of course, there are issues with this because these ducks might move from one location to the other, flamingos might move from one location to another, and so you might go one day and see 100 flamingos, go back the next day, and you don't see flamingos because they've all moved to some other water body. So those are problems. Those are problems. But at a location, if you're counting the number of ducks or flamingos at a particular time, you use usually direct counts. Um, but what is doing transits on birds? Is it not a difficult and cumbersome, if not tough process? Whenever you find a bird to calculate these values, so peacocks. Um, Usually, what happens in while walking line transit is actually not difficult to record these values. You actually come back and calculate the perpendicular distance from the line later. But when you're using the, that your transit is at a certain bearing, right? Let's say your transit is oriented from south to north. Then you're walking from 180 degrees to 0 degrees. So your transit is oriented to 0 degrees. Um, and as you're walking along the transit, usually what people do is either there will be two people walking together, and one person will be observing birds, taking the bearing and distances to these individual birds recorded, and then uh, dictate to another person who will then write that information down. Otherwise, what people do is that they use a voice recorder with a mic clipped to the clip to the shirt, and you switch on the recorder when you start the transit. And as you're walking along the transit, you dictate into the transit the time, the species, the bearing of the species, the angle from the transit, the species from the compass, as well as the straight line distance, sighting distance of the species. It's then after you come back and you've got all that information there, you've got time, species, bearing, and distance. Then the bearing and the distance is used to actually calculate the perpendicular distance using trigonometry. So the calculation is not being done on the line transit. So um, there will be many at a close distance. Let's say you have a flock of warblers, right? And you see this flock of warblers, and there are 10 warblers in the flock. Then what is done is you don't take the distance and bearing of each of those 10 warblers. You take the distance and bearing to the center of the flock. So even if you see large flocks of birds, you don't take this bearing and angle of every individual in the flock. It's to the center of the flock that the bearing and distance is taken. For ground birds, which are very tough to be seen in forest, but we know that they are there. Will the sampling give us valid non-biased? It might not. So, especially if these ground birds are not very vocal. So, when you're walking a transit, let's say there are lots of pittas in the habitat, but at the time that you're walking the transit, the pittas are not calling, and you're not able to see these pittas. Then the line transit methodology is not suitable to estimate densities of pittas because the bird itself is non-detectable from a line. In that case, you will not get estimates at all of abundance of a species like that. Um, So some other method has to be used for such species, maybe mist netting. Uh, you know. So, but otherwise, other ground birds, as in partridges, for example, We do see them while walking line transects, but often what happens is there's not enough data that we don't have enough records of these ground dwelling birds to be able to estimate their abundances reliably. So this will happen with all methods of sampling bird communities, where the commonest birds you will collect a lot of data about. So walking a line transect and one bird is very, very common, then I will have a lot of sightings for it. I will have a lot of data on sighting distance and sighting angle. And I will be able to reliably estimate its abundance much better than birds that are rare, where I see one individual or two individuals, and either rare or inconspicuous. They might be very, very common in the habitat, but you just never encounter them on transits. I'll give you an example of a passerine bird that we are familiar with from our work in Arunachal Pradesh. It's the snowy browed flycatcher. When we walk transits, we hardly ever record snowy browed flycatcher on our transits. But in mist nets, it's one of the five most common bird species in the habitat. So it depends on the species that you're studying, whether line transit methodology is going to work or not. Another question on call counts: is call count specific to some birds, as the other counts are not possible, or there is no other way to count? No, the call count is specific to certain birds because they are vocal, and because they are vocal and they hold territories. So if you're standing at a location, and this people do often with very vocal pheasants in the breeding season, you're standing at a location in a grassland, let's say, you can, I know that a bird that's calling from one location is a different individual from a bird that's calling from another location, right? So I can stand and say, okay, I can hear six sage grouse or whatever partridges calling from six different locations. So the call count is used for in species like that, species that are vocal, species that hold territories, where you can be almost 100% sure that a bird calling at 10 a.m. here is going to be calling at 11 a.m. also from there. It's not going to be moving to some other territory. The accuracy of this count. So if the bird is not vocal, if males are, so these are call counts are typically done for species that are males are calling during the breeding season. So if the birds are not calling, then call counts are not useful at all. Um, how do we identify the same but different birds calling? That's based on the assumption of, not assumption, based on our knowledge of the fact that these birds are territorial, right? So there will be certain birds calling from one location, other bird calling from another location. That's how we. And if only male birds call, then how do we make call count inclusive for females? Yes. Um, Very often, you just estimate the density of males. If you know that for certain species, uh, males will form a mating pair for the breeding season, and you know that for this species, male and female will form one mated pair during the breeding season, then the number of males should be equal to the number of females. So based on that, you make extrapolations. But in cases where one male might mate with three females during the breeding season, and those sorts of situations, maybe the call counts are not useful to estimate overall population size, but you might get only male population size. In a census counting, are teams given multiple patches of rectangular forest, and the subtotal of the counts become the estimated population. Typically, in forests, censuses are not done. Um, because detectability is so low for most, not so low, detectability is less than one for most species in forest. And so in forest, typically point counts and line transects are the sampling methodologies used to estimate bird population sizes. Um, on the other hand, if you've got grasslands or short grasslands where you can actually see birds, or you've got water bodies like lakes, there, yes, teams can be given different patches of the habitat, and then the sum total, and then they sample all the habitats at the same time, so that there's no double counting. They sample all their sectors at the same time, and then the sum total becomes the estimated population for the given species. In a given patch of forest, one draws the transect line and then counts the birds in the ESWs. No, the effective strip rates actually come from the data. So you're walking on the transect line, and all you're recording is sighting bearing and sighting distance, sighting angle and sighting distance of the species that you're seeing. You are not recording the effective strip width is not something that is predetermined. The effective strip width comes later from the data. So you take your sighting bearing and your sighting, so your line transect is like that, and your sighting angle is this angle, and sighting distance is this. Then this is the perpendicular distance from that is calculated later. Once you have all the perpendicular distances for all the sightings that you've seen, you then get a distribution of number of sightings from number of sightings at different distance classes from the line transect. That then tells you what the effective strip width is. So the effective strip width is not predetermined, it comes from the data. How does one cover patches of forest that does not cover the assumed rectangular patch and will not be the exact dimensions of the right? The forest might be of a different shape. The forest might be, let's say, a circular patch, but the transects will be lines. Within that circular patch, the transit will be lines. And there, in the rectangles around the lines, there is still forest. So it's not as if you are covering the entire forest, right? What you're doing is you are sampling a part of the habitat. You're sampling a subset of the area of the total forest patch. So even if your forest patch is irregularly shaped, you can still place straight lines in that habitat patch, and the tangles around the transects will still contain that habitat and still contain birds that are in that habitat. Further to the discussion on the difficulty of recording cryptic or skulking species, is there a statistical way to work around while using line transects, such as a way to extrapolate the counts to account for high degree of non-native? Yes, capture regions may not be always feasible due to a number of reasons. Uh, Generally, if you have cryptic species that don't vocalize, skulking species, then line transects are not the way to estimate their population sizes. One of the things that can be done, no, okay, so I'll put it this way. If you've got two species, one of which is very conspicuous and one of which is very skulking, then when you're walking the line, and both have the same abundance, both have equal abundances, right? But one is more detectable than the other. When you walk the line, you're going to have, let's say one is 10 times as detectable as the other, right? You walk the line, you'll have 10 individuals of species A, but only one individual of species B, because species B is inherently skulking. Now, if I need 40 detections to estimate effective strip width and line transect, and get abundances, then I have to walk the transect 4 times to estimate the population size of the species A, because each time I walk, I get 10 individuals, right? So if I walk 4 times, I'll get 40. If 40 is enough for me to estimate effective strip width, then 4 walks or 4 transects should be enough to estimate population size of A. But if I need to get 40 sightings of species B, then I have to walk 40 transects, right, to get at 40 sightings, because each time I walk the transect, I see only one individual of the species. So if you increase your effort, sampling effort, then you can potentially um, uh, uh, get at population densities of skulking species also, but maybe the effort required is very, very high to get at population sizes of these skulking species. Um, Sometimes what people do is, will say, I will categorize the 100 species that I have in my habitat into 3 detection classes. And so there's the highly detectable species, there's the intermediate detectable species, there's the low detectable species. And then I will fit different effective strip widths to each of these different classes of species, calculate the probability of detection, and then apply that to the raw counts to get at population density. But that's a more that is one of the statistical ways in which people have tried to say, okay, um, the detectability of this species should be similar to the detectability of another species. And so six species put together form one detection type, right? And then if I, instead of doing, instead of getting my effective snippet from the distribution of sightings of one species, I get my effective snippet from the distribution of sightings of all the six species put together. And so I have more data. I'm borrowing information across species. So that's one statistical way to go about doing this. Sachin says, what seasons are selected from census during a specific season or multiple seasons? Um, Depends on which species you're studying, right? If you're doing censuses for species that breeds in grassland, for example, and is most uh, conspicuous during the breeding season, then that's the season you would pick to do a census, because you want a detection to be almost one, right? You want detectability to be very, very high. Um, and therefore you will do it in a season where detectability is high. Now, on the other hand, when you're censusing waterfowl like ducks and geese, those are coming to India in the winter. They're not breeding in India at that time, and so the census would be done during the winter. So it's, since you would want to do a census when the detection probability is very, very high, because the detection probability is almost one. It should be one in a census, because the assumption is that you're not missing any individuals in the census. So as the bird count will be lower in a 10-meter radius, what is the optimum radius to be chosen for point count, like forest or grassland? There is no like almost everything in field ecology. There is no one number that can be applied to this issue of how big should your effective radius be. Like you point out, it depends on the habitat, right? So um, uh, in a grassland, you might say I can detect all individuals within a 100-meter radius, and so my effective radius, not effective radius, the fixed radius would be 100 meters. In the forest, I might say I can only detect with absolute certainty all individuals within a 25-meter radius. So then I say I will only count individuals within 25-meter radius. Now those are fixed radius point counts. These are not relying on distance sampling, right? They're fixed radius, and we're saying that within this radius, I'm confident that I'm not missing individuals. And so that depends on what kind of species you're studying, what kind of habitats you're studying. In distance sampling, you record all individuals regardless of what distance they're at, and you record the distances, radial distances to those individuals, and then arrive at the effective radius from the data. Do you think species can communicate about the danger of misnetting to others, which may reduce the probability of capture? Um, there are some species that when they're captured in misnets, they do give alarm calls, and so they might be warning. I mean, that might be uh, warning to other individuals of their own species. Whether it reduces the probability of capture or not, I'm not sure. Maybe, you know, when birds give alarm calls, sometimes what happens is in the presence of a predator, birds might give alarm calls. And when birds give those alarm calls, a number of other birds will come together to mob the predator. So it could work both ways. The alarm call might attract other birds to a potential, the other birds might think there's a predator and therefore might come to the mist net. Or they might avoid and then obviously tracking of people.
Okay, I just have one more question related to the. Uh, are you able to hear me? Hello.
I can't hear you. Can others hear, Mr. Pandare?
Yeah, we can.
Oh, one sec. Sorry,
Oh,
I just changed my settings.
hello. Or I'll type it. I think that will be better, efficient.
No, go ahead, go ahead.
Oh, okay. So I was just asking. I have asked these questions on the group also. What is the typical length that usually is used in the line or transect sensor method? I'm not saying exact. I know that it may vary based on the geographical location as well, or maybe the species or whatever. But typically, is it like 100 meter, 200 meter, 500 meter, or 1 kilometer? What is that?
It's between, it could be anything between 250 meters to a kilometer. Um, and in fact, in the habitat, when you put out the line transit, it's not necessary that all the lines have to be of the same length. So you could have one line that is 250 meters long because you can't find more. You get to 250 meters and there's suddenly a cliff and you can't go next on that line. Whereas in another location in the same habitat, you might find a place where you can place a line of 1 kilometer length. And so in those cases, people will place a line of 1 kilometer length. So even within the habitat, it's not necessary that all the lines have to be of the same length, but typically the lines are somewhere between 250 meters to a kilometer. That's the typical, for forest
Okay.
purposes at least, that's a typical distance.
Okay.
Can a reliable census of bird count be conducted from bird sounds or songs heard? Um, Depends on the species, especially when species are territorial, and you know that that you're standing in a location and a bird singing in one location is definitely not going to be singing from another location. Then in those cases, for those species, call counts can be used reliably. On the other hand, if the species is not vocal or it's very mobile and non-territorial, then a bird that you count here at 10 a.m. might be the same bird that you're counting somewhere else at 11 a.m. So, then in those cases, then call counts are not suitable to estimate population size.
And for usually for such census, it's usually driven by the forest officer or the government authority. Is it correct?
Uh,
For
for
in,
censuses,
yeah,
yes.
for census, will it be usually governed or driven by the forest official or the government body only, or can other people or citizens also do initiate the census?
Uh, so the forest department does conduct censuses in different parts of the country, different states, different forest departments either conduct censuses or don't conduct censuses. But that's typically towards larger, usually birds are not censused by forest departments. The censusing or sampling larger mammals like tigers and elephants. But individuals can apply to the forest department to do this kind of work and apply for a research permit. And if you receive a research permit, then that allows you to enter, a national park or a wildlife sanctuary or a reserve forest. You get that permission, and you get permission specifically to do the kind of research that you have proposed. Then individuals can, if they get that permission, they can conduct, do line transects or mist netting or conduct censuses. A lot of individuals are also are engaged in what is called citizen science, where people. So if in my neighborhood itself, I can upload the list of birds that I see every morning, or if I visit, Kaziranga National Park or Corbett Tiger Reserve, I make a list of all the bird species I see, and I can upload lists onto a site called eBird, and that's one way in which citizen scientists can contribute um, their sightings and their records to the larger scientific process. Uh,
Right, because yeah, because I was asking this question because recently I applied for Nagarhole bird census because at some point of time they also want to kind of advertise or maybe market or add some more details about a particular tourist spot, be it a Nagarhole or Kabini or something. What other avifauna is available apart from a typical tiger, a leopard, or something that might attract the tourists? This is what my thinking was when I said forest department might just conduct the census. Yeah, thanks.
right. So very often the forest department might say it's too dangerous. If you apply to do, if you apply to, let's say, do line transects in Kaziranga National Park, then I think the forest department will very rightly say, the Assam Forest Department will very rightly say, it's tall grassland, there's no visibility, there are five species of very, very dangerous, potentially dangerous animals here, and therefore
Mm.
we will not give you permission to do this kind of research. When you not walk through the forest, but maybe we will give you research to do transects from a jeep or something like that. So yeah, safety concerns are there in some national parks. Um, but then the risk is borne by the visitor and the researcher, and it's not really the responsibility of the forest department to ensure 100% safety all the time for people who are in the field.
Yeah, you're right. I mean, I wanted to say that the initiation for Nagarhole census was done by the forest department itself, and people were able to apply to that. I think it happened in January and February time frame. So that's what I was referring to. Yeah.
Right, right. Thank you. Yes, uh, but that would be for large for mammals, right? It would be for many.
No, that was only specifically for bird census. So they had asked or invited birding enthusiasts and bird watchers to come and do the birding census there. Yeah.
Sachinji, I'm sorry
Oh,
to
that's great.
interrupt. Sachinji, these are all citizen science initiatives where common people are also called for covering the whole area for the census. And each group will have one expert, one a newcomer, and also one person who knows the area, like a ranger or something. So it's
That's right.
unless and until you enlist public, you can't cover the whole area of the forest to survey or something. So the actual nitty-gritties of the survey is taken care of by the experts. Those people who go along with the experts, they have an experience, and they get an experience also, and they can understand the scientific thing. Because I have participated in recently in January. Tirupati Bird Atlas, where the bird atlasing was a completely different scientific phenomena, and it was very new to me. But then again, I also participated in Hosur survey, which was a much more relaxed and informal way of surveying. So I have the experience of both the scientific as well as informal surveying. all I have found is that the experts take the onus on them. They know the area, they have birded there already, and they know the bird species, what to expect and where to expect. And the way they count is, it's sometimes for a newcomer like me, it was like mind blowing experience.
True.
Thank you very much for sharing that, Ms. Lakshmi. In case of territorial birds, there will be individuals unable to have territories. How are they included in the population count? What usually happens in highly territorial birds is that is what is called a despotic distribution, which is the high quality individuals in the population will occupy high quality territories first. And once the high quality territories are occupied, the lower quality individuals end up defending lower quality territories. Um, and therefore, in many species, what happens is every individual does have a territory, but the territory might vary in size and quality and so on. But in the case of species where some individuals have territories, but a number of individuals are unable to establish territories and they're just floating around in the population, then they cannot be sampled using call counts or territory counts. Um, in those instances, market recapture is perhaps the best way to estimate population sizes, because you can also estimate the probability. I mean, getting into more technical details here, but you can estimate the probability of an individual being a floater, being transient. And so market capture would probably be the best way to estimate populations of those kinds of species. Well, I suppose if there are no other questions, we can end this session.
Yeah, I was about to say, like, wait for 2 more minutes and then end the section, probably.
Sure.
Yeah, I think if everyone's agreed, then we can close the session, I suppose.
All right. Thank you all. Thank you so much for joining, and thank you and for your questions. I hope you got something out of this. And thank you, Jordan and JP, and the studio team for arranging this. See you next time.
Thank you.
Thank you, sir.
Thank you.